This is Pre-Calculus Concept 19E. We're going to be talking about finding the domain of a logarithmic function. We've got three boxes. So on the right here is just a graph of a basic logarithmic function. Remember that it's got a vertical asymptote at x equals 0. Remember that it goes through the point 1, 0. And if you think about the inputs that make sense for this function, since it only exists to the right of the x-axis, we want to make sure that we understand that the domain is all numbers greater than 0. So we're going to see some variations of this where rather than being log base b of x, it's going to be log base b of some function involving x. And all we need to remember in order to find the domain is that we have to find the values that make g of x a positive quantity. So in other words, the thing that you're taking the log of has to be a positive number. Otherwise, the function won't work, and our domain has to include only those values. Alright, let's look at a couple of examples of this. I think you'll catch on pretty quick. The first one, f of x equals log base 10 of x plus 3. The base in these problems is kind of irrelevant because we're just talking about finding the domain. And so I have to think about what would make that function greater than 0. So that's a little just mini side problem. X plus 3 has to be greater than 0, which means x has to be greater than negative 3. That is the domain for this problem. Any number greater than negative 3, when you plug it back in, is going to give you a value that works out, and therefore that's the domain of your function. Okay, number 2, g of x log base 5 of 2x minus 5. Once again, I'm looking at the thing that I'm taking the log of, and I have to make sure that that function, 2x minus 5, is greater than 0. 2x would have to be greater than 5, and x has to be greater than 5 halves. Your domain for this function is the set of all x such that x is greater than 5 halves. Alright, last one, same thing. I'm going to look at what's the log of what I'm taking the log of, and make sure that that's greater than 0. This problem is a little tougher. Well, you may remember it from the end of last chapter, but I actually have to think about this in a slightly different way. The best way to think about it is by factoring this. Thinking about the equation first. Okay, and so the values that would make this equal to 0, I'm going to put those on a number line, are negative 2 and 2. And if I do a little sign analysis, anything bigger than 2 when I plug it in here is going to give me a positive number. Anything between negative 2 and 2, like 0 for an example, is going to give me a negative answer. And then anything left of negative 2, like negative 3, is going to give me a negative times a negative, which is a positive. Okay, so this is a little sign chart for this equation. I'm looking specifically for when the function is greater than 0, and so my answer should be these positive parts. Okay, a couple ways you can represent your answer. If you did it on a number line, it would be everything strictly greater than 2, so open circle there. Let me do that again, sorry. Should be an open circle at 2 and then everything to the right. Open circle at negative 2 and everything to the left. So that would be one way of representing the domain. If you want to do it with inequalities, it would be x is greater than 2 or x is less than negative 2. Okay, we could also do interval notation. We'll do one more version of this down here at the bottom. We could say negative infinity comma negative 2 with a bracket, and then union 2 to infinity. So not necessarily to give all these different versions of the same thing, but you can give your answer in inequality form, in interval notation, or you could give your answer on a number line like this. But all of those represent the domain for this function. They're values that would make the logarithm work out. And that's the idea behind domain of a logarithmic function. Alright, we'll finish up with a you try. Take a look at this function below and see if you can tell me what the domain is. Think carefully before you answer. Alright, hopefully you thought about this in the exact same way as our examples. The stuff inside the logarithm, in this case 3x minus 2, has to be a positive quantity for this to work out. 3x has to be greater than 2, and x therefore has to be greater than 2/3. X greater than 2/3 is your domain for this function.